All right, this question says, what is the rate constant expression for this reaction? And we have the overall reaction, and we have the mechanisms, so the first step and the second step of the mechanism. And we also note that the first step here is the rate determining step. So when the first step is the rate determining step, that's really nice because the first step of the mechanism has reactants in it. It may not have both reactants in it, but it's definitely not going to have intermediates in it. If you look at the second step of the second step of the reaction has an intermediate in it, which is not in the overall reaction, and that becomes much more challenging. But in this case, since these are elementary reactions, or these are the reactions that are directly occurring, we have rate equals K, concentration of NO squared, because there's two of them, concentration of H2, because there's one of them. Because these are elementary reactions, you could just use the stoichiometric coefficients in the rate law because these things are actually interacting in order to form these. And since this is the slow step, it's known as the rate determining step. So it's the one that's going to be in the rate law. You will notice that this does not match the overall reaction. So in previous questions, we've only looked at the overall reaction. In some cases, we needed to determine this value and this value. You can't use the stoichiometric coefficients of the overall reaction because you don't know the mechanism. But here we know the intermediates or the elementary reactions. Said another way, we know the mechanism, and therefore we can use these directly to determine the rate law. Note that you can only do this if it's the first step. If it's the second step, you can't do that because you can't put H2O2 in the rate law because it's not in the overall reaction. But for the first step, it always has to be reactants in the overall reaction. It doesn't have to be the same stoichiometric coefficients. It doesn't even have to be both of the reactants, but it does have to be those reactants. So that is basically how this works.